7.4, solving log equations and inequalities. This whole lesson's all about how to solve log equations. So let's get to it. Okay, before we start though, actually, there's a couple things we have to go over. First, let's talk about the domain of log x actually. If you remember when we did last class, our log graph looks kind of like this. It's a brief rendition. So your domain of a log equation is x is greater than or equal to 0. I mean, just greater than 0, not equal to. Because that's by 0. So what does this mean? Now, this means that log x cannot be negative, or 0 actually. X could be negative, as long as you plug it back in. As long as you plug it in, you don't get a negative for log. Like if you ever try to do log of negative 2, that makes no sense. Or log of 0 makes no sense. So if you get anything like that, then it's no solution. Your x could be negative if you have something to this effect. Right? I have a negative answer, I plug in, it makes it positive. Right? So it's all about checking your work. It's kind of like to plug it back in. Log x cannot be negative or 0. That's the first thing. The second thing is, there's a rule we haven't talked about yet, and that's this. If you have a base to a log with the same base, so that looks kind of funky, right? That's like saying this, 3 log base 3 of x. What happens here is, anytime the base of the power, base of the number is to a power with the same log base, these cancel out and you just get x. So anytime you have 3 log base 3 or 5 log base 5, they're going to cancel out, and you just get the bigger number, the big number, x. So that's the second rule. And why is that important? Because that's one of the main ways we solve this. Now, there's actually 2 ways to solve these type of equations, and let's do the first way first, which is just rewrite it. Rewrite it. Find your base. So it's be 9, right? Base to the power, so 3/2 equals x. Now we gotta figure out what 9 to the 3/2 is. Remember we talked about this? You always want to do the root first. So it's gonna be the square root of 9 cubed. Square root of 9 is 3. 3 cubed is 27. That's the first way to do this. That's what I used to do when I was in high school, was just rewrite it and solve. But now there's actually a little faster way. I'm going to do that next. So way 2 is we're going to do it, that second row here. We're going to try to create that. So see how 9 is my base? We're going to do this. We're going to take 9 to the base of both sides. So let me show you what that looks like. You don't have to, and when you're doing your work on to show this work, you just kind of go take 9 to both sides and then stuff cancels out. So let me show you what it looks like. It looks like 9, so log base 9x equals 9 to 3/2. What happens here is that these cancel out, and you get x equals 9 to 3/2, which we already did, and we know is 27. I know it's essentially the same thing, but that's the way we're gonna be doing it. We're gonna do it more mathematically. We're just take the 9 on both sides, and also added bonus, it's an easier way to rewrite it, right? So that's the idea. So let's do this one. I see the 16 right there. I'm gonna take that base to both sides, so 16 to this and 16 to this. These cancel. I get x equals 16 to the 5/2. Remember, always do the root first. So we're going to do square root of 16 to the 5th. Square root of 16 is 4. And 4 to the 5th is that I have no idea. There's some big number there. But I'm guessing 1024. I'm actually pretty positive about that right now, but we'll see. And it is. I double checked. Sometimes I got skills. So, next thing. Right, let's do a couple more to make sure we got this. And, okay, let's make sure it's a little different. Right, same idea here. Here's your base 8. So we're going to take 8 to both sides. So take 8 here, 8 here. These cancel. You're going to x equals 8 to the 4/3. Hopefully you're getting a little better at this. So that's going to be the cube root of 8 to the 4th, which is 2 to the 4th, which is going to be 16. Right, onto this one. Same thing. Oh, there's a base. Let's just take that to both sides. Get that stuff out of here. X is equal to 16 to the 3/4. Do the 4th root of 16, which we just kind of did the backwards thing right here, right? 2 to the 4th root of 16. So the 4th root of 16 just be 2. 2 to the 3rd is 8. Right? So that's the basic way to solve a log problem. So when it's super basic, you just take the base of both sides to cancel out the logs. Now let's get a little fancier, but actually easier. So what happens if you have a log on both sides, right? The last one we just did, right? We just came away from log on one side. And I want you to understand that, oh, where it's the base, take that on both sides. These cancel. X equals 3 squared, or 9. Right? That's what you solve when there's only one log. Well, 2 logs, how does this work? Well, the same idea. What's the base? 3. Take it to both sides. These cancel, and you get x squared minus 15 equals 2x. Notice again, yeah, it works, right? It only works when logs are when logs have the same base. So you're not, but that's one way it could work. You can't do it by hand without if the logs are different bases. At least with stuff we learned so far. Anyway, I'm here. Remember the way you gotta solve this? It's a quadratic. Set equal to 0 and set and factor, right? Like we always do. Semester 1's back again. So set equal to 0. Alright, subtract 2x from both sides, so it's a negative 2x, and we're going to factor. Two things I multiply to get negative 15, but I get 5 is 5 and 3. The middle is negative, so 5 is a bigger number, is negative. Split it, and I get x equals 5 and negative 3, right? Set that equal to 0, 0 property rule. Solve. Now remember the thing I said earlier? X, remember, log cannot be negative. Now, if I plug these in, let's look at this one because that's a little easy. If I plug in 5, I get log 10. That's fine. This checks out. If I plug in negative 3, I'm going to get log 3 to negative 6. Can't have that. So that's not an answer. My answer is only x equals 5. Right? Remember, log can, my answer could actually be negative, but log, when I plug in it, it can't be negative or 0. So another one real quick. Same idea here. Let's take 12 to both sides. These cancel. X squared minus 7 equals x plus 5. Set equal to 0. Minus 5 minus 5. Right, factor it. X minus 4 and 3. I can do math. Split it. X equals 4 and negative 3. Negative 3. Right, now let's check these. Plug in 4. If I plug in 4 here, I get 4 plus 5 is 9. That works. Plug in 4 there, 16 minus 7 works. Let's check negative 3. Negative 3 plus 2 is actually log 2. That's fine, right? Again, even if it's a negative, when I plug it in, it works. Plug in negative 3 here. Negative 3 squared is 9. 9 minus 7 is 2. Again, that works out. In this case, they both work. Right, so it's not just when it's negative. Make sure when you plug it in, the log is not negative. In this case, they're both positive. It works. Both my answers are good. Next step, let's talk about log inequalities. Log inequalities, the way we do these is very similar to square root when we did the square root inequalities. Right, we have to worry about the domain. That's the thing I meant to say. So step 0, I always like to say, is find a domain. So when we do log inequalities, there's a domain that we have to worry about. So we have to find a domain first. Now, domain for logs is just the thing inside the log has to be greater than 0. Right? Not greater than equal to 0, just greater than 0. That's my domain. So let's do a couple. This first one here. Let's find my domain first. My domain. Let's just get this. That has to be greater than 0. And that's it. That was quick and easy. Now let's solve this. Right, so we're going to take the base of both sides. Now notice there's only one log, so the way we solve the log is always the same way. Take the base of both sides. These cancel. X is greater than equal to 4 to the third. So x is greater than equal to 64. Now as always, you kind of want to see what the answer is. So you have to be greater than 0 and greater than equal to 64. And it's the overlap, so it's just actually this. As always, when it's greater than, most of the time it's just going to be the answer. When it's less than, most of the time it's going to be the intersection. Not always, because it depends. It could get a little funky right here, but the general rule is if it's a basic one, greater than doesn't take care of the domain, you have to worry about it. When it's less than, you have to worry about it. The general rule. But again, sometimes it's going to be a little bit different. So, let's do this one. All right, same thing, let's find my domain. Hey, it's another easy one. Done. Now let's solve it. Take the base of both sides. These cancel. X is less than 2 to the 4th, which is 16. So I got x is less than 16, x is greater than 0. So I'm going to be somewhere in between those two. Oof. No, not equal. Not equal. So you're going to be somewhere between 0 and 16. Again, if I graph it, here's 16 going that way. That's an open circle. Here's 0, you're going this way. And you'll be somewhere in between those two. That's the general rule of how to solve inequalities. Sitting is like solving logs. So I'm actually gonna, we'll do one of these. Let's do this one. Let's do both, I guess. Let's find my domain first. X is greater than 0. So easy. Let's actually solve it. Here's your base. Take 5 to both sides. So x is greater than 5 to the third. So x is greater than 125. So x is greater than 0 and 125. It's only be this one, because that one's greater than both of them. That's your answer. Here, find my domain. Done and easy. Solve it. X is less than or equal to 8 to the negative 2. Remember, that just flips it. That's all negative power does, is flip it. So it's 1 over 8 squared. So x is less than or equal to 1 over 16. If you're not sure, you could graph it. Here's 0. Open circle. Here's 1/16, really close to 0. This is a closed circle this time. You're going that way. So it's overlap. You're in between those two answers. Let's do the same thing with log of most sides. This is probably the final one we do. We're gonna now, the temptation is to take 3 to both sides, right? But again, we gotta worry about the domain. In this case, we actually have 2 things. So we're about the domain on both of them. So the domain on that top one there, or it's the left one, I should say, 7x minus 6 is greater than 0. Right, a lot fancier than the domain we had earlier, which was just like zeros. This actually has something inside of it. So my domain here, just add 6 divided by 7. It's greater than 6/7. My domain for this guy, 4x plus 9 is greater than 0. So, solve, subtract 9 divided by 4 is this. And now we actually got to solve it. Let's take the 3 to both sides, right? Whatever the base is, take that to both sides. These will cancel. 7x minus 6 is less than 4x plus 9. Do a little math. Minus 4x plus 6 plus 6. I get 3x is less than 15. Divide by 3. X is less than 5. So I have all this stuff here. I have these 2 domains. I have this. If you want to figure out what the answer is, the easiest thing to do is probably just graph it all, see where we land. So negative 9/4 is over here. Open circle that way. 6/7 and 5. 6/7 is less than 5, so 6/7 will come next. Same idea, it's going that way. And then 5 going the opposite way. Remember, the way this works is where's everything overlapping? That's right here, from here to here. So my answer is going to be in between 6/7 and 5 is the only place I could actually have an answer. So x is going to be between 5 and 6/7. And that's the idea.